Good morning, everybody. Today we will discuss the importance of fingerprint region and functional group region in IR spectroscopy. Okay, IR region is usually represented in wave number. In wave number, it is in between 4000 centimeter inverse to 600 centimeter inverse. IR region comprises 4000 centimeter inverse to 600 centimeter inverse in the electromagnetic spectrum, right? Among this region, functional groups absorb above 1400 centimeter inverse. The region below 400 centimeter inverse, that is up to 600 centimeter inverse, that is the region between 400 centimeter inverse to 600 centimeter inverse is usually referred to as fingerprint region. The region above 1400 centimeter inverse, where the functional group absorb the IR radiation, is usually referred to as functional group region, while the region between 400 centimeter inverse to 600 centimeter inverse is usually referred to as fingerprint region. Okay, and what is the importance of this fingerprint region and the function group regions? In fingerprint region, almost all the types of bending vibrations and certain single bond structures such as C single bond O, C single bond C and C single bond N, and also some bands due to the benzene rings are found in fingerprint region. And because of these many vibrational absorption bands or a large number of infrared bands, the spectrum obtained here is highly complex. The spectrum obtained in the fingerprint region is highly complex because of a large number of infrared bands obtained here. Okay, but the many bands there provide a fingerprint for a molecule. These complicated bands provide a fingerprint for a molecule. That complicated bands are usually referred to as a fingerprint for that particular molecule. Okay, while it is very difficult to pick out any specific functional group identification from this region, it does nevertheless contain valuable information. This fingerprint region gives valuable information about the compound. Just like a human fingerprint, the pattern of absorbance peaks in the fingerprint region is unique to every molecule. The pattern of absorbance peak obtained in the fingerprint region is usually unique to every molecule. Thereby, the data obtained from an unknown sample can be compared to the IR spectra of non-standards in order to make a positive identification. That is how the molecules identified using IR spectroscopy. Okay. Thus, as the spectra obtained in the fingerprint region is unique for a molecule, as the fingerprint of the human is unique for that particular person, we can identify the molecule by comparing the fingerprint spectra of the molecule with that of IR spectra of non-standards to identify the molecule. Okay, that is how the molecule is identified by using IR spectra. Okay. Now let us consider the importance of functional group region. Many functional groups absorb infrared radiation at about the same wave number, regardless of the structure of the rest of the molecule. For example, CH stretching vibration usually appear between 3200 and 2800 centimeter inverse. That is 3200 to 2800 centimeter inverse. And carbonyl stretching vibration, that is C double bond O vibration, usually appear in between 1800 centimeter inverse and 1600 centimeter inverse, that is 1800 to 1600 centimeter inverse. So all these types of infrared bands obtained for the functional groups are called group frequencies, and because they tell us about the presence or absence of specific functional group in a sample, and they are all called group frequencies, and the region above 1400 centimeter inverse is usually regarded as functional group region, and all these appear above 1400 centimeter inverse and is called functional group region. Okay, so we have seen that every molecule, when absorb IR radiation, it forms a complex spectra in 1400 centimeter inverse to 600 centimeter inverse. Even though no functional group can be detected in this region, the complicated spectra is unique for a molecule, as the fingerprint is unique for each of the human being. Hence, this region or this complex spectra is called fingerprint spectra, and this region is called fingerprint region. Okay, by comparing the data obtained in the fingerprint region with an IR spectra of non-standards, we can identify the given compound. Okay, that is how we can use the fingerprint spectra or spectra obtained in the fingerprint region to identify the given organic compound. Usually by comparing the data obtained in the fingerprint region, this fingerprint is compared with the standard IR spectra of a non-compound. That is how we can identify organic compound. Similarly, a particular functional group absorbs same wave number in any organic compound, regardless the rest of the group present in the compound. Thus, we can identify the functional group by noting the position of the band appeared in the functional group region. Any particular functional group has a specific region where the band appeared in the functional group region. By noting this position of the band appeared, we can identify which functional group is present in the compound. Okay, and so we can say IR spectra or infrared spectra is used to identify the functional groups and also identify the nature of compound. Okay, then see these two infrared spectra. It is of 1 propanol and this spectra is of 2 propanol. You can see similar vibrational bands or IR bands are obtained in both the cases at below 1400 centimeter inverse. I mean above 1400 centimeter inverse, that is the functional group region. In both the cases, similar bands, vibrational bands are obtained in the functional group region. This indicates both the compounds having same functional group. For example, this broad spectra obtained at around 3300 centimeter inverse is because of the presence of OH group. In both the cases, you can see this broad spectra that is obtained at the 3300 centimeter inverse 3300 centimeter inverse frequency. Then you can see there is a strong band at around 2900 centimeter inverse in both the cases because of the presence of carbon hydrogen sp3 stretch in both the cases. Carbon hydrogen sp3 stretch in both the cases. So we can say similar spectra are obtained in both of these cases in functional group region. Then if you compare the fingerprint region, you can see different spectra are obtained in the fingerprint region for both the compounds. This indicates these are two different compounds, and hence this fingerprint region or the spectra obtained in the fingerprint region is used to identify the organic compound. Here you can see both having different fingerprint, even though they have similar spectra in the functional group region. Okay, thus we can say by using the fingerprint spectra and the spectra obtained in the functional group region, we can identify the functional group, and also we can find the nature of organic compound. I think you might have got a clear idea about the importance of functional group region and fingerprint region in infrared spectroscopy, and how is it each of them are used to identify an organic compound. Okay, with this discussion I conclude this video. Thank you for listening.